Welcome to Real Civil YouTube channel. In this video I am going to show you how to design a G+2 story building in etab software. For this you will need a plan and column position. You have to draw first center line. How to draw this center line, I have made a video already, so you can check that video. Link is in the description box. Okay, now you need to save this plan or center line in DXA format. Okay, then you can come to etab software. For etab I have already saved one file. I will tell you one by one. First go to file, import, then DXA file of architectural grid, then go to the project where you have saved, etab CN. Okay, click on this, click on open, meter, select etab, which is the format of that particular line I have saved. Okay, give any name, just click on save, yes. Okay, now the grid is, we have imported the grid lines. Now we have to place the column position. Before that you have to go to define material properties, then define M20 HYSD 500 mile 250. Okay, I have already defined. Then section property, make frame section of beam 230 by 380, that means 9 inches by 15 inches. Similarly 9 by 18. Then column, whatever you want, define it. Similarly go to slab section. I am giving 1 inch one way and 2 way. Okay, now open the plan and see the column positions. Okay, we have to mark the column position first. So go to draw, quick column, then I will select column 230 by 380, then column positions 1 to 3. So this one is, so I will just cancel it out. And before going to actual draw, I will go to edit stories and grid system, modify show. Here you can write as a ground floor, then this one as first floor and terrace, or second floor, whatever you can write. And or you can, if you want to design for future, so you will include the load on terrace also. Okay, so I will click this as yes, and this will as a no. I will make this as a master story, and this story will be similar to the first story. Okay, terrace will be similar to the first. I am going to design it as a for future. In future, suppose they will build on terrace, there is another one floor, so I make it master story. So click on OK. Some modification to grid system, like here just go with A, B and C. Okay, so there will be less confusion. So okay, now we can select here all stories, and now we can draw column 230 by 380, first, second, third, then fourth and fifth. I think the fourth one is at this level, fifth one is here, and now two more are here. There is another column here, there is another one, and Okay, I think this column is at this place. Okay, so I will select and delete this column. Now go to draw, quick draw column. Okay, now 1 2 3 4 5 6 7 8 9 10 11 number of columns are there. So 1 2 3 4 5 6 7 8 9 10 11. Okay, now go to draw, quick draw beams. I will select beam 230 by 380. Okay, now you can see where we need to draw the beams. You have to click accordingly. Now here we will join these two and make this as one, but before that we will first mark the column beam. Now we need to join these beams. Then there are few more beams are there. I think yes. Okay, first we have marked all the beams as per the required drawing. Now we will join. Okay, so go select the beams you want to join. I think here go to edit frames, join frame. Okay, now you can see this one as a single frame. Now I will select horizontal. I think okay, edit frames, join frame. Now I think every frame is continuous. Let's check once. Here there is no problem. Okay, now our next job is to provide releases. This beam is secondary, this one is secondary, this one, then this one is secondary. So select all these beams, go to assign, frame, release, select this, apply. Okay. Okay, now there are some beams like this one you need to release. I think right in. Okay, this one is released, this one is released. Now for this beam, assign, frame, release, apply. Okay, now we need to release this end, will act as a simple support. So I will, now this beam will act as a simple support and give point load to those cantilever, two cantilever beams. Frame, then release. I want both, apply. Okay, I think we have given all the releases. Okay, now our next job is to draw slab. Okay, so go to draw rectangular floor. So first I will draw all the two-way slabs. Okay, so before that I will just delete this. I will go to similar story option. Okay, so on the ground floor there will not be any slab. First I will draw the two-way slabs. Okay, for this I will select different option. Okay, now one by one I will select. Okay, now we have to assign one-way slabs. Okay, so for that I will choose option one way. You have to change the direction. I will teach you how to change the direction. This one is okay. Okay, so I need to change the direction, so I will select these two slabs, assign shell local axis. I will select 90, apply. Okay, now you can see that distribution is on these two particular beams. Okay, now I will go to define load pattern. I will create super dead load case in which I will apply brickwork load and floor finish. Add OK. Now first we will select all the floors according to IS 875 part 2. The live load for residential is 2 kilonewton. Hence I will go to shell loads uniform. I will select live load 2 kilonewton per meter square, apply OK. Now here you can see on the 2 kilonewton per meter square has been applied. Now again select the previous selection, go to assign shell load uniform, select super dead load. In super dead load we will apply 1 kilonewton per meter square. That means our floor finish. And dead load of the slab is automatically calculated by etab in dead load load pattern. So we no need to apply self-aid. Okay. Now our next job is select all storage, and we will select one in floor and select the outer beams where we will apply the wall load. Here there is a balcony, hence I am not going to apply that full load. So here we will apply 0.23, means 9 inches wall at a height of, if we deduct the beam depth, then we will get clear height 2.62 into 19, and that will comes around 11.44. So after selecting outer beams and all stories, go to assign frame loads distributed. Here just select super dead load, and that value comes around 11.46. You can calculate on your own, apply OK. So on all the floors that load has been applied. Now select the inner beams. I will select all the horizontal first. This one. Okay, now vertical 2, 3, 4, 5. This one is horizontal. I think we have selected all the internal beams on which there is a 6 inches wall. 6 inches by height 2.62. By deducting the beam depth, and into 19, so that comes around 7.46 or something. So assign go frame load distributed 7.46 or 7.5, apply OK. Now we will select the balconies. Okay, here there is only 1 meter height, up to 1 meter height there is a load, so we will assign 4.9 super dead load, apply OK. Now we will go to the base, select, go to assign joint restraint fixed, apply OK. Now go to define load combination for our general G+1 building. 1.5 dead load plus live load plus super dead load is enough. So just give the factor of 1.5, then add, select live 1.5, add super dead load 1.5, OK. OK, I think we have applied dead load, live load, floor finishes, wall loads, properties have been given, fixed support have been given, load combination has been done. So now go to analyze, run analysis. So this is the analysis part, and if you want to see that your model is correct or not, then you can check the bending moment diagrams. Okay, if you see the A part here, this A part elevation, go to elevation A, apply OK. Now here you can see there is a bending moment diagram of simply supported beam. Okay, and we have assigned simple support here. So if you want to see the display deforms or combination, show values, apply OK, then you can check. If you go on upper floor, here you can see the load is 4.9 kilonewton per meter. Then on upper floor there is a slab load. Because of this slab load and wall load, the bending moment diagram is slightly more. Okay, here you can see 16, then 23, 23. That's why there is an increase, because on ground floor there is no any slab load. Okay, so here you can see the results. You can check here for live load. Our live load is 2 kilonewton per meter square. Okay, so here length is 3.5267. I will just check 3.5267 divided by 2. Okay, so that is our UDL is of 0.920 kilonewton per meter at 3.5267, and the bending moment diagram you can see here. Okay, so we can say that our whatever diagram or etab's analysis is correct. If you have this 0.92, I will show you how to check. This is 0.92. Okay, so 2 kilonewton per meter square is the live load. Okay, so 2 into 0.92 divided by 2. Okay, WL by 2, half load of 0.92 on this beam, half load of 0.92 on this particular beam. Okay, so 0.92, here you can see 0.92 is the UDL. That's how it come, and the length of this beam is 3.5267. Our simply supported formula is WL square by 8. So into 3.5267 into 3.5267 divided by 8, 1.5 4303 kilonewton per meter. Kilonewton meter is the moment. That means our load distribution is correct. Okay, this is the way you can analyze the building. To design, I will make another video in which I will tell you how to design it on RCDC, how to import the file of etab in RCDC. Okay, thanks for watching the video. Please like, share, subscribe the channel. Thank you so much.